Hello, hello, hello. This is week 23 of Python for Everybody. We are really at the. We really need to come to terms with things, or we are coming to terms with things. Where should I even address? Um, yeah, the last stream, I was sitting here for an hour already, and I was trying to think, how should I even approach this? Because I really feel like, I lost the track. There were a few times I was really into it, and I was really actually thinking that I'm learning something, and I'm actually thinking I'm deep inside the program, or let's say in the language, and I'm really trying to, in like kind of like a Zen mode, like literally I really felt it when I was learning about the string module and how do you use the punctual, how do you remove punctuation and everything. So but of course, time after time, you're gonna get you lose track. Life happens and everything. Over this past 23 weeks, it was like this. I would say the beginning was like this, and then a drop, and then trying to go up and up. But now we are again. We hit the rock bottom. And I don't want to sound overly negative. And I know at the moment it feels like, absolutely, it feels devastating. I was sitting here and I don't even know how to even approach this. And the more I think about it, the more I feel this really, like a really actual burnout feeling. Like that my brain is, like my brain cells are just over it. And literally physically, I can feel like the, ah, and this is not a healthy place to be. We don't want to be in that place, and it's sad that we are here. But on the other hand, this is a momentary, like this is something we have to take seriously, that this is not normal, this is not what it's supposed to be. And it doesn't mean that it's always going to be. I'm very hopeful, uh because no. um so yes, that we reached the point where we lost track of all of the information, and the most importantly, we are very confused about even the beginning, because there are just too many days have passed without actually practice. So yesterday I wanted to use Coursera to, like, okay, let me just try to first test, like the first assessment, because I always followed the book. And I, of course, for example, this was the code. Like in chapter 3, um, exercise this one, for example. What is the rate? Exactly this. Um, so this is the task. And this, like when I was doing this weeks ago, and I did this, I know I figured this out. Okay, it's nothing special, but I felt so like accomplished about little things like this, and it was working. And then I was trying to do it on the test, and it's not accepting. And what the hell? And immediately I felt like closed the laptop and like, okay, I'm not dealing with this now. But what I'm trying to say is that this stream, what was our original goal was to uh, finish the book, and then decide, and then move forward. And definitely I feel like, I really felt like I was hoping that while I'm recording, or while I'm streaming this whole book, by the end we're gonna be this, really, that we are a bit gonna look megvilágosult. I don't know the word, but that we're gonna be more confident about our skills or about our things. And I do not feel this way, absolutely not. And I just feel the, and it is what it is. But yeah, what I'm trying to say is that I should finish the book, just really like active reading, active note taking. And it's okay to not, if you don't fully get this. And then we're gonna continue to the last chapter, we're gonna also do the same thing. And then when everything is done, I will, on my own pace, again start it from Coursera, from basically from the first video, because I do feel like if I give myself the chance to just rewatch again from the beginning and redo the course, I still now I am aware about things. I'm aware about all of the tools and methods and whatever you have in Python. So definitely this was not going to waste. It's just crazy. It's been 6 months, and yeah, this is where we are now. So yeah, this is again. I was hoping I can do some good motivational speech, but the more I speak, the more I feel the despair and like that. Yeah, not a great feeling. Oh, I'm showing you guys the struggle. If any kids are watching this, just fucking learn, okay? You are 15, you're 16, you have all the time. Don't fucking spend your time on this, okay? Don't fucking spend your time. You can, okay? It's amazing. We have video games and you have all the options to entertain yourself. But if you are not in a family where this can spawn or anything, if you're not in that situation, just this is your primary. Like make it work for you. Use your time, because that's the whole. What did we take away from all of this is that if we don't have outside sources like work and responsibilities, and all you have is free time, then learning is actually like very cool thing. Like it does make sense if you have all the time, but you need all the time, like, because there's so much out there that doing it these weekends and then next to work is just crazy, absolutely crazy. And you don't want to end up in this situation where if you don't do this, you are just stuck with your job, and then yeah. Oh yeah, on the other hand, yeah, music. So I started to spend more time with music again, like practice. And that's the other thing. You have to find something you really like, to make something you're passionate or interested about to be your source of income. And yeah, that would be the ideal scenario. So 11 o'clock, 30 minutes ago, I had one pill. So let's do it. Let's do it. I watched the ending of the last stream. I was really burned out, and I was trying to watch the video. So that's why what I'm gonna do really. I'm the source we're gonna watch. Here's my notes and the book, and I stopped here. And yeah, just reading out loud. It's like gonna be an ASMR stream. This is kind of like, I think my therapist told me about this. It's like passive learning. Like you're not, this is not something you do now, but you read it now because maybe time later it's gonna be, it's gonna be subconsciously stored. So without any concern, I'm just gonna go ahead and read this. We are adding the unique keyword to text columns that we would like to have a uniqueness constraint that we will use in insert ignore statements. This is more succinct that separate create index statements, but has the same effect. With these tables in place, we write the following code tracks underscore csv.py to parse the data and insert it into the tables. You can see that we are repeating the pattern of insert or ignore followed by a select to get the appropriate artist underscore ID and album underscore ID for use in later insert statements. We start from artist because we need artist underscore ID to insert the album, and we need the album underscore ID to insert the track. If we look at the album table, we can see that the entries were added and assigned a primary key as necessary as the data was parsed. We can also see the foreign key pointing to a row in the artist table for each album row. We can reconstruct all of the track data following all the relations using join/on clauses. You can see both ends of each of the relational connections in each row in the output below. This example shows 3 tables and 2 one-to-many relationships between the tables. It also shows how to use indexes and uniqueness constraint to programmatically construct the tables and their relationships. Up next, we will look at the many-to-many relationships in model. Some data relationships cannot be modeled by a simple one-to-many relationship. For example, let's say we are going to build a data model for a course management system. There will be courses, users, and rosters. A user can be on the roster for many courses, and a course will have many users on its roster. It is pretty simple to draw a many-to-many relationship as shown in figure 15.7. We simply draw 2 tables and connect them with a line that has the many indicator on both ends of the lines. The problem is how to implement the relationship using primary keys and foreign keys. Before we explore how we implement many-to-many relationships, let's see if we could hack something up by extending a one-to-many relationship. If SQL supported the notion of arrays, we might try to define this. Sadly, while this is a tempting idea, SQL does not support arrays. Or we could just make long string and concatenate all the user primary keys into a long string separated by commas. This would be very inefficient because as the course roster grows in size and the number of courses increases, it becomes quite expensive to figure out which courses have student 14 on their roster. Instead of either of these approaches, we model a many-to-many relationship using an additional table we call a junction table, through table, connector table, or join table, as shown in figure blah blah blah. I cannot even click on it. The purpose of this table is to capture the connection between a course and a student. In a sense, the table sits between the course and the user table and has a one-to-many relationship to both tables. By using an intermediate table, we break a many-to-many relationship into one-to-many relationships. Databases are very good at modeling and processing one-to-many relationships. An example member table would be as follows. Following our naming convention, member.user blah blah are foreign keys pointing at the corresponding rows in the user and course tables. Each entry in the member table links a row in the user table to a row in the course table by going through the member table. We indicate that the combination of course underscore ID and user underscore ID is the primary key for the member table, also creating a uniqueness constraint for a course ID slash user ID combination. Now let's say we need to insert a number of students into the rosters of a number of courses. Let's assume the data comes to us in a JSON formatted file with records like this. We could write a code as follows to read the JSON file and insert the members of each course roster into the database using the following code. Like in the previous example, we first make sure that we have an entry in the user table and know the primary key of the entry, as well as an entry in the course table and know its primary key. We use the insert or ignore and select pattern so our code works regardless of whether the record is in the table or not. Our insert into the member table is simply inserting the two integers as a new or existing row depending on the constraint to make sure we do not end up with duplicate entries in the member table for a particular user ID combination. To reconstruct our data across all three tables, we again use join/on to construct a select query. Oh, I thought so. Okay, so this. Actually, yeah, I wouldn't mind just going continue. We are reading it through. I literally wouldn't mind. Yeah, I literally wouldn't mind. Let's just, yeah. I'm gonna read through so that the stream is gonna be complete. We're gonna literally read through the book. And then, yeah, then I'm gonna start again. Or not, but yeah, I will. Well, we have presented the join table as having two foreign keys, making a connection between the rows and two tables. This is the simplest form of a join table. It is quite common to want to add some data to the connection itself. Continuing with our example of users, courses, and rosters to model a simple learning management system, we will also need to understand the role that each user is assigned in each course. If we first try to solve this by adding an instructor flag to the user table, we will find that this does not work because a user can be an instructor in one course and a student in another. If we add an instructor underscore ID to the course table, it will not work because a course can have multiple instructors. And there is no one-to-many hack that can deal with the fact that the number of roles will expand into roles like teaching assistant or parent. But if simply we add a role column to the member table, we can represent a wide range of roles, role combinations. Let's change our member table as follows. For simplicity, we will decide that 0 in the role means students and 1 in the role means instructor. Let's assume our JSON data is augmented with the role as follows. We could alter the roster.py program above the incorporate role as follows. Notice that because we declare the ID column in the role table as a primary key, we could omit in the insert statements. But we can also choose the ID value as long as the value is not already in the ID column and does not violate the implied unique constant on primary keys. Are you kidding me? This chapter has covered a lot of ground to give you an overview of the basics of using a database in Python. It is more complicated to write the code to use a database to store data than Python. It is more complicated to write the code to use a database to store data than Python dictionaries or flat files, so there is little reason to use database unless your application truly needs the capabilities of your database. Exactly, that's why I don't even know why we are needing this right now. The situation where a database can be quite useful are when your application needs to make many small random updates within a large data set, when your data is so large it cannot fit in a dictionary and you need to look up information repeatedly, or free when you have a long-running process that you want to be able to stop and restart and retain the data from one run to the next. You can build a simple database with a single table to suit many application needs, but most problems will require several tables and links/relationships between rows in different tables. When you start making links between tables, it is important to do some thoughtful design and follow the rules of database normalization to make the best use of the database capabilities. Since the primary motivation for using a database is that you have a large amount of data to deal with, it is important to model your data efficiently so your programs can run as fast as possible. One common pattern when you are developing a Python program to connect to an SQL database, SQLite database, will be to run a Python program and check the results using the database browser in the SQLite. The browser allows you to quickly check to see if your program is working properly. You must be careful because SQLite takes care to keep two programs from changing the same data at the same time. For example, if you open a database in the browser and make a change to the database and have not yet pressed the save button in the browser locks the database file and keeps any other program from accessing the file. In particular, your Python program will not be able to access the file if it is locked. So a solution is to make sure to either close the database browser or use the file menu to close the database in the browser before you attempt to access the database from Python to avoid the problem of Python code failing because the database is locked. So this is something, of course, we can make a load. So to connect. I don't know how to write this in different words. Close the database before you attempt. Why is it not a word? Attempt. attribute. I'm sorry, I don't know why I'm shouting. One of the values within a tuple, more commonly called a column or field. So that's the thing. What did I get in 23 minutes? 23 minutes. 23 weeks of studying, or 23 weeks of being involved, let's say with Python. What is tuple? Tuple is like a list. It has two. You separate them with a column, and they are immutable. You can store them as keys to a dictionary, and that's it. But what can I do? Why would I even use tuples? No idea, absolutely no idea. So that's it. It's okay, Gergely. If you can fix your brain, nothing was in vain. When we tell the database to enforce a rule on a field or a row in a table, a common constraint is to insist that there can be no duplicate values in a particular field. Enforce a rule. Rule on a field or a row in a table. Yeah, I'm actually hopeful about this now. Like, that's a very nice idea. Just use the Coursera course, but really start it from the beginning. Really. But I just feel like, I have this tendency, and even with music as well, like to go through the beginning, it's just, I feel the boredom. Like, it's like, ugh. But it's like, if you time it well, then it's, if you set your expectations that it's, if you don't want to rush, it's gonna be fine. It's gonna be fine, Gargay. It's okay. So far, we have been learning the Python language and then learning how to use Python, the network, and databases to manipulate data. In this chapter, we take a look at 3 complete applications that bring all of those things together to manage and visualize data. You might use these applications as sample code to help you get started in solving a real-life problem. Each of the applications is a zip file that you can download and extract onto your computer and then execute. So let's do tea break. No. Yes, I need a sock on me, socks, and yeah, I will get a tea. So tea. Let me put the music for you on. So let's build building OpenStreetMap from geocoded data. In this project, we are using the OpenStreetMap geocoding API to clean up some data. Some user entered geographic locations of university names and then placing the data on an actual OpenStreetMap. To get started, download the application from blip. The first problem to solve is that these geocoding APIs are rate limited to a certain number of requests per day. If you have a lot of data, you might need to stop by. If you have a lot of data, you might need to stop and restart the lookup process several times. So we break the problem into two phases. In the first phase, we take our input survey data in the file where.data and read it one line at a time and retrieve geocoded information from Google and store it in a database geodata.sqli. Before we use the geocoding API for each user entered location, we simply check to see if we already have the data for that particular line of input. The database is functioning as a local cache of our geocoding data to make sure we never ask Google for the same data twice. You can restart the process at any time by removing the file geodata.sqlite. Run the geoload.py program. This program will read the input lines in the where.data, and for each line, check to see if it is already in the database. If we don't have the data for the location, it will call the geocoding API to retrieve the data and store it in the database. Here's a sample run of after there is already some data in the database. Magyarország. It's not opening, by the way, it's not opening. Interesting, very. It's PC is doing weirdo shit now. 1, 2, 3, 4. I'm gonna open it in Python directly then. Okay, it's open. No such file or directory where data. So the whole day is raining. Very nice. I mean, this is the perfect day for sitting at home. No stop raining. I have no idea what's going on. Why are you working like this? Okay, I'm gonna just... Yeah. I don't know what's going on. I will have to restart, guys. I'm gonna restart. The computer is doing weirdo shit. So maybe if I just pause, is there any way I can pause this? No, it's okay. So I'm gonna just continue from here, okay? I